Hello, detectives. Mrs. McKay here. Just ready to move on to the next learning target clue, which is 2-2 for our case 2. And our learning target is I can graph. So go ahead and write the word graph right here. I can graph a linear equation using the x and y intercepts. I can graph a linear equation using the x and y intercepts. Now, before we go any further, let's do a little review, shall we? So intercepts, when we talk about intercepts, we are talking about the coordinate plane. So let me draw over here an x and y axis. So this is x and this is y. And an intercept is where a line crosses either the y-axis or the x-axis. And we know in the slope-intercept form of a line, y equals mx plus b, that the b, the constant in the equation, when it's in this form, represents the y-intercept, where a line crosses the y-axis. So let's say that I have this line right here. There's my line. And where the line crosses the y-axis looks to me like it's about, we'll say 1. Right here. Well, we'll call that 2. We'll say that that's 1, 2. So right there is where it crosses the y-axis. So that's called the y-intercept. And where the line crosses the x-axis is right about there. And that also looks like it's about at 2, if we said that was 1, 2. That's called the x-intercept. Now, as I mentioned, in the y equals mx plus b format of a line, when we put a line in that format, whatever number is in this place where the b is, that's the y-intercept. So it's pretty easy to find the y-intercept if we have a line in y equals mx plus b format. But we don't always have a line in that. And so to avoid having to rearrange our equation and put it in this format, we can actually identify the y-intercept and the x-intercept pretty easily. And we're going to talk about that in just a minute. And the way that we can do that is because we know something about the y-intercept and we know something about the x-intercept. And that is, we always know one part of the coordinate point. So let's talk about coordinate points really quickly. Let's see. A coordinate point is the ordered pair. It's the two numbers that are the location of a point on a coordinate plane. So let's look at this one, for example. If I put this point right there, that actually has a location. Let's see if we can do this. 1, 2, 3. We'll say it's 3. This location is 1, 2, 3, 4 over, and 1, 2, 3 up. So 4, 3. It's the x and the y, right? The coordinates are the x and the y. So this is 4, 3. That's this point. Every point on a line has an x and a y. Every point has an x and a y. All right? It doesn't matter where it is on the line, it has an x value and a y value. And that is true even of our y and x-intercepts. So we've already said that this y-intercept crosses the y at a positive 2 on the y-axis. What is the x value of that point? We know that it's something 2, but what is the x value? Well, it's 0, isn't it? If we were going to graph the point 0, 2, we wouldn't go anywhere along the x-axis, but we'd go up 2. So the y-intercept is 0, 2. And the same way, the x-intercept, we know what the x is. It's 1, 2 over, but what's the y? Well, the y is 0. So you'll see this on every single line that crosses the y-axis. If it crosses the y-axis, the y-intercept will always have a 0 in the x part of the coordinate point or of the ordered pair. And the x-intercept will always have a 0 in the y part of the coordinate point. And that's because it isn't moving anywhere. It's sitting on the axis. Those are important things for being able to find out the x-intercept and the y-intercept when we're given some points or given a line. So let's go ahead and go over here to this first problem. It says, find the x-intercept and the y-intercept and graph the line. So I'm going to start by saying, let's go ahead and find the y-intercept first. So if I was going to find the y-intercept, I would take this equation and I could do it two different ways. I could put it in y-intercept form and then I could find the b. But that looks like a lot of work. It looks like I'd have to subtract this 2x, I'd have to divide everything by 3, and that's just a lot of work to just find one thing. But what do I know about the y-intercept? I know that whatever the y is, the x is 0. And that's true on every line. So if the x is 0, that should be able to tell me what the y is. And if you can remember back that on a line, a linear equation, the x and the y represent the different points. Every x and y pair that make it a true statement are a point on the line. So that means that the y-intercept must be 0 for the x something. And it's just the y that I need to find out because it's somewhere along this y-axis. All right? So if I put 0 in its place, in the place of x, and solved for y, that should be able to tell me what the y-intercept is. So I'm going to do that. I'm going to take this x and I'm going to replace it with 0 because I know for the y-intercept, 0, x is 0. So I have 2 times 0 plus 3y equals 12. Well, 2 times 0 is 0 plus 3y equals 12. I'm going to solve for y by dividing both sides by 3. That 0 goes away. And I have y equals 4. So my y-intercept is at 4. X is 0, y is 4. So 1, 2, 3, 4. I'm going to go ahead and graph that point. That's my y-intercept. Well, what about my x-intercept? How can I find out what my x-intercept is? Well, I do the exact same thing, but this time I know that for my x-intercept, my y has to be 0. Remember over here where I wrote 2, 0? This x-intercept was 2 on the x-axis, but 0. It didn't go up or down in the y's. So how about if I write it up here? If I say 2x plus 3y equals 12. And now I know that I'm finding what the x is, and I already know that the y is 0. So then I just have to replace that y with a 0. So I have 2x plus 3 times 0 equals 12. Well, the 3 times 0 just becomes 0, and I end up with 2x equals 12. When I divide both sides by 2, I get x equals 6. So my x-intercept is at 6 and y is 0. So that means 1, 2, 3, 4, 5, 6 is right there. So now I've just graphed my y-intercept and my x-intercept. And once I have 2 points, all I have to do is connect them, because then I've made a line. And remember, both of these points are on this line, and we know that they're on the line because if we put 0, 4 into this equation, we're going to get, it's going to be a true statement. If I put 0 in for x, I get 0 plus 3 times 4 is 12. 12 equals 12. That's a true statement. So this is a point on the line. 0, 4 is a point on the line. Same is true for 6, 0. Put 6 in for x, I get 12. Plus 3 times 0 is 0, so 12 equals 12. So 6, 0 is a point on the line because it makes it a true statement. Every point on the line, if I put the x and the y in for it, will be a true statement. So now all I have to do is draw my line by connecting my two points, which I'm not so good at drawing lines. Let's see if I can just make one this way. There we go. And I always, when I draw a line, I want to put my little arrows on the end because my line goes on and on and on and on forever. So now I've just graphed a line. I didn't have to use slope-intercept form. I didn't have to use slope. All I needed was an x-intercept and a y-intercept, and I was able to do that very easily by just plugging in 0 for x to get my y-intercept and 0 for y to get my x-intercept. Let's see if we can do a few more. -3 plus x equals 9. So let's start by finding our x or our y-intercept. So our y-intercept means that we're going to be looking for, right over here, x is going to be 0 and the y is what we need to figure out. All right? So because the y-intercept is where the line is going to cross the y-axis. So it's the y that we need to know. It doesn't move off of the y-axis, so x is 0 in this case. So let's go ahead and put 0 in for x, and we end up with -3y plus 0 equals 9. When we divide by -3, I'm just ignoring that 0 now, we get y equals -3, right? 9 divided by -3 is -3. So our y-intercept is 0, -3. Let's also, I'll go ahead and graph that right now. 1, 2, 3. There's our y-intercept, 0, -3. Now let's go ahead and graph our x-intercept. And once we've done that, we should be able to graph it, just connect the two dots. So our our x-intercept is going to have, that's the thing that we're trying to figure out. We don't know what the x is, but we know that the y will be 0 because it's not moving off the x-axis. It's staying right on the x-axis. So now I'm going to replace the x with 0. I'm sorry, not the x. I'm going to replace the y with 0, and I get -3 times 0 plus x equals 9. And so this ends up being 0 plus x equals 9. So therefore, x equals 9. So my x-intercept is at 9 on the x-axis, 0 for the y. So let's go ahead and graph that one. 1, 2, 3, 4, 5, 6, 7, 8, 9. I think I counted right. Yeah. So now I have an y-intercept at -3, an x-intercept at 9, and I just need to connect my 2 points. I hope that you are doing the same thing on your paper, that you're writing down what I'm doing and that you are drawing these lines, because that's going to help you to remember this. Don't just watch, watch and do. One more to do. One more to do. Why don't you take a minute? Here we have another linear equation. This one actually happens to be in slope-intercept form, but we have y equals 4x plus 2. What do you think the y-intercept is? I'm going to give you a second, and I want you to figure out what the y-intercept is. There's 2 ways you can figure it out, and I'm going to see if you can do it. So go ahead and figure out what the y-intercept is. Now, there's 2 ways that you could have figured that out. You could have said, well, Mrs. McKay, this is in y-intercept form, and I know that the 2 is b, because I have y equals mx plus b. The b is the y-intercept, so it must be 2. The y-intercept must be 2, and therefore it's 0, 2. Or you might have said, well, I know that x is 0, so if I put 0 in for x, 4 times 0 is 0, and all that's left is 2, so y must be 2. Either way works, and it should. Both ways should work. So we know that our y-intercept is 2. And let's go ahead and graph that right there. Go ahead now and see if you can figure out the x-intercept. The x-intercept. Remember, the x-intercept is going to, we don't know where on the x-axis it crosses, but we do know that the y is 0. Go ahead and take a minute and see if you can figure out what the x-axis, the x-intercept is on this one. Well, what did you find out? Let's go ahead and do that one together. Y is going to be 0, right? I'll just write it one more time. Y equals 4x plus 2. I'm going to take that 0 right there, and it's going to be in the place of the y. So I'm going to write 0 equals 4x plus 2. And now I'm just solving for x. So I'm going to subtract my 2 from both sides, and I get -2 equals 4x. I'm going to divide by 4 on both sides, and I get -2/4 equals x. But -2/4 can actually be reduced to a -1/2. So x equals a -1/2. Is that what you came up with? -1/2, 0. So now if I want to graph this x-intercept, I'm going to have to graph a -1/2, 0. Now that's not the end of the world, because here's -1 right here. So -1/2 would be right about there, halfway between the two. So that's my -1/2, 0. Notice that it's still on the x-axis, that it hasn't gone up or down, because the y is 0 in this situation. And the last thing we can do is connect our two dots. Sorry, it's a little crazy. And put our little arrows on the end. And we have just graphed this line. All right? So that is graphing a line using the x and y-intercepts. Pretty simple. The only time that it gets tricky is when you start dealing with fractions. And so this last one was a little bit trickier because we were going to have to graph a fraction. And it gets more difficult when you're graphing, say like 3/7 or something like that. And if you want to be accurate, then sometimes graphing the x and y-intercepts isn't always the best solution, and it's better to go ahead and just graph a line in slope-intercept form. But in general, this is a nice and quick and easy way to graph the x and y-intercepts. All right, so now the last thing that you need to do is to come down to the bottom of your page and write some key ideas. What are some key ideas that you need to remember that will help you to remember this so that you don't have to look through everything? And it could be or it could even be a mistake that you want to make sure that you avoid. One mistake that students make often is they think that on a y-intercept, the y is 0. But it's actually just the opposite. On the y-intercept, the x is 0. And on the x-intercept, the y is 0. So it's like the opposite coordinate is 0 for that axis. So that's kind of an important thing to remember because you don't want to get mixed up if you are asked to find the y-intercept or the x-intercept. You want to make sure you know which letter is being replaced with 0. So just always know that to find you're going to look for y equals something. That's the y-axis. So you have to make the other variable x be 0. Hope that makes sense, and I will see you in class.